In this training video, we will learn how to add wall framing, panelize the walls, add wall panel macros such as panel breaks, generate parts, and create wall panel drawings. Before we begin drawing the wall framing, let's review a few settings we covered in the first two training videos, set up in walls. Set up Vertex to frame the full length of the walls, or panelize the wall framing for specific lengths. In this project, the main floor walls will be framed to full length. We will set up the second level walls to be panelized. Let's begin on the first level wall layout. Switch the layout to the first level wall layout, go to Drawing Model Pairs, and select First Level Wall Layout. When we created this project in the first training video, Intro and Setup, we covered a few settings that contribute to the wall framing. Under Project Document Browser, expand Settings, Location and Height, and select 3D Levels. 3D levels control the wall heights and floor depths for each level. For the first and second floors, we assigned a 12-inch deep floor system. Zoom in on the first and second levels in the cross-section. We have assigned a height of 9 foot 1 1/8 for the first level, and a height of 8 foot 1 1/8 for the second level. Unless we modified the wall heights for an individual wall, all the walls will be assigned these heights. Select Cancel to close the window. Project parameters control the wall framing parameters for each level. Project parameters are under the Project Document Browser, under Settings, Design Setting, Project Parameters. Here you can set up the wall framing to frame the entire length of the wall as one wall segment, or set up Vertex to panelize the walls to preferred lengths. For each wall framing set, you can assign the panel break max length, minimum length, and preferred lengths. When adjusting the length also needs to be changed for each wall type. Below are tabs for exterior bearing walls, exterior non-bearing walls, gables, interior bearing walls, and interior non-bearing walls. For the first floor wall framing, we will frame the walls full length without any panel breaks. Set the max length and preferred lengths to a large number. Let's assign 800 inches to both fields. Remember to change the fields for each of the wall types for the first level wall framing. For the second level wall framing, we will panelize the walls using the default max length and preferred length settings. All the second level wall types are assigned the default settings. The default window rough opening height can be assigned under the level wall set. For each level, the default is set to 82 inches. We will leave it as the default for all the wall levels. Select OK to close the window. In the second training video titled Walls, we covered wall frame tools. The wall frame tools are rules assigned to a wall that instruct Vertex to which framing materials to assign to a wall framing details, on-center stud spacing, framing around openings, and various other wall framing settings. Wall frame tools is part of the wall framing layer within a wall type. To view wall framing tools for a wall type, go to the Modeling tab, Wall Layout, and select Walls. In this example, we will select the exterior bearing 550 library. Select the 550 S162-54cc exterior bearing wall type. Under the Layers section, select the Frame layer, 5.5 inch framing. Right mouse click and select Frame Tools. The type, tool library, and tool for the wall is displayed. You can access a different wall frame tool from the Tool drop-down field. Under the General tab, you can set the panel label, assign framing details for corners, backers, and panel ends. You can also set the horizontal bracing and blocking materials, set the top track detail and select the materials for the top track, top stud, and extra track. You can also select the bottom track detail and materials, set the stud material, quantity, spacing, and other settings. To change the detail, click on the Select button next to the detail. In the Detail window, click on the diamond next to the detail to select the detail. I'll select the X in the upper right corner to close the window. Under Openings, set the details and materials for the top header, opening header, and sill. Assign materials and quantity for the jamb and kings. You can also adjust the same settings for headers number 2 and number 3. For headers 1 and 2, you can set the maximum length for those headers. Assign materials for cripple and studs above and below the openings, as well as assign the jamb and king orientation. Under the NC Tooling tab, set the heights for the service holes. Add in-stud web holes, and add web holes to top and bottom tracks. Select Cancel to leave the settings as is. Select Cancel again to close the wall library. You can change the framing tools for a specific wall. Double-click on the family room back wall. Select the framing layer, 5.5-inch framing. Right mouse click and select Framing Tools from the menu. You can change any of the framing tool settings for this specific wall. We will leave the framing tool settings as is. Select Cancel, and select Cancel again to close the wall library window. Now that we have our wall framing settings assigned, we can proceed with panelizing our first level walls. The wall panel tools are located under the Modeling tab, Panel, Wall tool. We will cover the basic wall panel tools, like the Panel Break macro, the Generate Panels and Generate Parts programs. We will also add some additional macros found under the Wall Panel Layout Accessories library. Macros are small programs or tools that tell the software to add additional framing components at a specific location. We will also add special framing around an opening. Special framing is a framing detail that overrides the framing tools that have been set in the wall type. Before building the wall panels, the framing macros must be added first. Let's start by adding a Panel Break macro. The Panel Break macro can be found under the Wall Panel menu and under the Wall Panel Layout Accessories library, under Building Components, Wall Panels. Double-click on the Panel Break macro. The status bar at the lower left corner is prompting us to select a wall to assign the panel break to. Next, select the front wall. We will add a panel break 18 feet from the lower left exterior wall corner. With the mouse cursor on the corner, set the Q key to use it as a reference point. Now move the mouse over to the right and type in 18 feet in the distance field. You'll see that the panel break symbol has been added just to the left of the exterior front door. Right mouse click and select Exit to end the panel break macro command. Next, let's add some double studs in the exterior wall that are in line with the 2 stairwell walls. Go to the Wall menu under the Modeling tab and select Wall Panel Layout Accessories. Double-click on the Extra Studs to Floor Plan macro. Next, select the exterior front wall. In the Extra Studs to Properties window, you can adjust the settings and save a preset, load a preset, or edit a preset. You can also assign a label to the macro. Under Studs, you can assign a different stud profile. The Profile field should match the profile that is currently assigned to the selected wall. The orientation, number of studs, and stud direction can also be adjusted. To change the profile or orientation, click on the Select button next to the setting. In the Stud Orientation window, there are several orientation options. You have toe to heel, toe to toe, box, and heel to heel. Click on the diamond next to the detail title to select it. I'll select toe to heel. Set the number of studs to 2. And select OK to leave the other settings as is. Next, select the exterior wall again. To set the location, select the center line of the stairwell wall. Select the other stairwell wall to add the other double stud macro. Select the escape key or right mouse click and select exit to close the command. Now we have two double stud macros in line with the stairwell walls. Let's add one more macro. Let's add a beam pocket to floor plan macro. At the family room, we have a drop beam spanning from the kitchen corner over to the right exterior wall. Let's add a beam pocket macro to support the right beam end with additional studs. Since the beam rests over a window, for training purposes, we will move the window over so it is in line with the sliding glass door. To move the window, select the window, then click on the middle grip point of the window. Let's move the window so it is centered with the sliding glass door. Click on the middle of the sliding glass door to line up the window. Notice how the window dimensions adjusted when we move the window. Select the escape key to unselect the window. Let's add one more macro. We will add the beam pockets to floor plan macro to add a beam pocket to support the right end of the beam. Before we add the macro, we need two pieces of information. We need the width of the supported beam and the distance of the bottom of the beam to the top of the first floor sheathing. Select the F2 key to switch to the 3D view and select the house icon to switch to the framing model. Zoom in on the second floor drop beam. Select the Verify Distance tool from the toolbar. To get the beam width measurements, select the bottom corner of the beam, and then select the beam corner at the opposite side. On the left side, you'll see the Verify Distance panel. We have a distance of 5¼ inches wide for the beam. To get the distance of the bottom of the beam from the top of the floor sheathing, we will click on the sheathing corner and then select the bottom corner of the beam. Select Cancel to close the Verify Distance panel. Go back to the toolbar and select Verify Distance again. Next, select the bottom corner of the beam and then select the corner of the floor sheathing. If there's enough space, the distances will be displayed on the screen. As you can see, we have a distance of 8 foot 5 inches or 101 inches from the sheathing to the bottom of the beam. Select the Cancel button in the Verify Distance panel or hit the Escape key to end the command. Switch the model back to the architectural view and press F2 key to go back to the 2D view. Let's go back to the Wall Panel Layout Accessories menu and select Beam Pocket to Floor Plan macro. Click on the right exterior wall to add the beam pocket. In the Beam Pocket Properties window, we can set a preset, load a preset, and edit a beam pocket preset. You can also assign a label to the beam pocket. For king side, select the drop-down field and select both to add a king to each side of the beam pocket. You can also change the profile of the king, set a quantity, and change the orientation. For jamb height, set that to 101 inches. That is the measurement of the bottom of the beam to the top of the floor sheathing that we obtained. Leave the jamb profile and orientation as is, and leave the number of jambs set to 2. Set the pocket width to 5½ inches to allow for the 5¼ inch wide beam. Set the clip sheathing side to interior to only remove the wall sheathing or drywall from the interior side. Select the OK button to accept the settings. Next, click on the right exterior wall. With the beam pocket macro linked to the wall, we need to set the location of the beam pocket. Select the wall center line of the exterior wall at the kitchen. This will line up the beam pocket with the center of the wall. To exit the command, select the Escape key or right-click and select Exit. We now have a beam pocket in the wall for supporting the right end of the beam. We went over just a few examples of the wall panel macros available in Vertex BD. You will find the macro library has a number of macros available for use. Let's go over special framing. Special framing for openings allows the user to create a framing detail for openings that require different framing than what was set up as a default under the wall framing tools. In this project, we will create special framing and apply it to the sliding glass door. The special framing tool is found in the Wall menu under the Modeling tab Panel section. In the Opening Special Framing utility window, there are tools for editing the special framing details, such as add a new special framing detail, edit an existing special framing detail, or deleting a special framing detail. To create a new detail, select Add New Special Framing Detail. The status line in the lower left corner is prompting us to select a wall. Select the wall of the sliding glass door to obtain the wall framing properties. Create special framing to override the default framing tool settings for openings. The settings can be saved as a preset for future use. You can load a preset and edit a preset. The Set Studs button copies the king stud materials to selected stud pieces, while the Set Tracks button copies the king track material to the selected tracks. You can add a label to your special framing. Use the Label button to add additional information to the label. Use the Header ST or Opening Header ST button for setting the stiffener and shoe track properties for both of these header types. You can assign details for the top header, opening header, and sill. You can also change the stud and track material for each detail as well as the jam and king materials. There are options to add cripples above and below the openings and set the jam and king orientation. To change a detail, click on the SEL button next to the detail name. Let's change the opening header detail. Click on the SEL button. In the opening dropped header window, you can select any of the available details. In this example, select the box header detail D-box by clicking on the diamond next to the detail. We will leave all the other settings as is. Select the OK button to accept these settings. Next, zoom in on the sliding glass door and select it to assign the special framing detail to the opening. Select the Escape key or right mouse click and select Exit to end the command. Let's move the label to the inside. Move the cursor over to the center of the label to find the grip point. Select the grip point and move the label over to the right side of the sliding glass door. You can see the label is made up of asterisks. That's because we didn't change the label default field. The additional jam and king material are also part of the label. Now that we've added wall panel macros and special framing around an opening, we can move on to generating the wall panels. There are several ways to access the Generate Panel tool. One is to select a specific wall, then right mouse click and select Generate Panels from the context menu. And another way to access the Generate Panels tool is to go to the Modeling tab, Panel section, and select Wall. Select Generate Panel from the menu. In the Wall Panelizing Settings window, you can adjust settings on how to panelize the walls. You can make adjustments to the settings and save the project-specific settings or reload default settings. We will cover just the basic settings. Under Structural Layers, you can set the layers to include or exclude when panelizing a wall. Under Corner Details, set how you want the corner details handled. Options include vertical walls extend, horizontal walls extend, clockwise orientation, or counterclockwise orientation. We'll skip the wall panel settings. Those usually do not require any adjusting. Under Set Panel Label Using, Wall Attributes uses the label set in the Wall Framing tool. Wall Type can be used to override the label set in the Wall Frame tool. Use the Panel Label section to apply a panel label ID and number. Currently, it is set up for an E prefix for exterior and an I prefix for interior panels. Both will begin with a panel number of 1. The first panels will have a panel ID label of E1 for exterior and I1 for interior. You can set the panel to have an interior view, and you can leave out layers which do not have any framing tools, such as siding and drywall. There are additional panel settings under the Advanced, Batten Settings, Corner Details, and Attach tabs. I'll set the panel label back to Wall Attributes and use the labeling system assigned in the Wall Frame tool. Select OK to apply our settings. Next, we need to select the walls to panelize. You can select Ctrl-A to select all the walls, or you can drag a crossing window around all the walls. By clicking on the upper right corner, keep the left mouse pressed and drag a window down to the lower left corner to select all the walls within the window. Right mouse click to select OK, or V key to confirm. Vertex will panelize the walls and assign a wall panel label to each wall. Zoom in on the exterior wall panel label at the kitchen. The wall panel label ID for this wall is 1E2. 1 represents the first floor level, E indicates it is an exterior wall, and 2 is the number assigned to the wall panel. The asterisk indicates a wall panel drawing has not been created for this wall panel, or the panel framing has changed, and the wall panel framing is no longer in sync with the wall panel drawing. To remove the asterisk, generate a panel drawing for the wall. Select the Shift-A key to zoom out. Now that we have generated our wall panels, the next step is to create the wall framing by using the Generate Parts tool. To generate parts for a specific wall, select the wall panel label, right mouse click, and select Generate Parts from the context menu. The Generate Parts tool can also be accessed from the Modeling tab, Panel section, Wall menu. You can individually select panel labels. You can also press the Ctrl A to select all the panel labels, or you can filter select the panel labels. Let's select all the wall panels with a selection window. Click on the upper right corner of the model, keep your finger on the left mouse button, and drag a selection window down to the lower left corner of the model to include all the walls. Right mouse click and select OK, or press V to confirm to generate parts. Vertex then goes through the process of generating the parts. Zoom in on the back corner of the family room. You can see we have framing at the exterior walls and framing around the openings. Zoom in on the interior wall panel label near the stairs. The interior wall panel has been assigned the ID 1I6, 1 for first floor, I for interior, and 6 is the ID number assigned to the wall. We also have framing applied to all the interior walls. Now that we have the main floor wall framing completed, let's switch to the framing model. Select the F2 key or select the switch between 2D and 3D icon. Select the house icon to change the model from architectural to the framing model. The framing model displays the first level wall framing and first and second floor framing. Let's hide the second level floor framing so that we have a clear view of the wall framing below. Select the Model tab at the lower left corner to switch to the Model Tree panel. To hide the second level floor framing, select the second level floor branch and right-click to bring up the menu. Select Hide to hide the second level floor framing. The 3D framing model shows all the parts that make up a framed wall, such as headers, jacks, kings, and other parts of the wall. Zoom in on the beam pocket framing. If you recall, we set the macro to only remove the interior side of the sheeting at the beam pocket. To view the beam pocket framing, select the exterior sheeting at the beam pocket, and then press the H key to hide the sheeting. Zoom in on the beam pocket to see the framing. The jacks and kings were assigned in the beam pocket macro. Next, let's view the double studs we added to the right of the front door. We use the extra studs to floor plan macro to add the double studs in line with the stairwell walls. To view the double studs, select the two pieces of sheathing to the right of the exterior door, and select the H key to hide each piece. We place these studs to be in line with the interior stairwell walls. And just to the left of the door is a wall break. We added the wall break using the panel break macro. Editing wall framing in Vertex is easy. You can edit within the framing model, or you can isolate a wall to focus only on a single wall, without the distraction of the rest of the framing. To edit the framing in a wall, zoom in on a wall and select a framing member. To move a profile, click on the midpoint grip and move in the desired direction. Use the U and I keys to constrain it along an axis. Right mouse click on the mid grip point to access some basic editing tools like the Move and Copy commands. I'll select Copy to add another stud. Right mouse click and select Exit or the Escape key to end the command. Manually extend a profile by clicking on an end grip. When moving an endpoint, the constraint is automatically locked. To cut a profile, select the profile and right mouse click, bring up the Edit menu. Or you can select the command from the menu ribbon. Select Cut from the menu. Select the point on the profile to place the cut. Next, I'll select the top piece and press the Delete key to remove it. There are additional tools for editing a profile end. Select the profile and right mouse click over the end grip. There are commands for moving a profile end, trim to plane, cut with a plane, and additional connection tools. Let's extend the profile ends to the bottom plane of the top plate. I'll use the Trim to Plane tool to achieve this. We'll need to adjust our view in order to select the bottom plane of the top plate. Next, select the plane. If we adjust our view, the profile is now extended to the top plate. I'll manually adjust the other profile by selecting the top grip and selecting the point along the bottom edge of the top plate. Editing wall framing can also be accomplished by isolating the wall panels. This is done by selecting a wall panel in the 2D view. Select the F2 key to switch back to the 2D view, and change the model back to the architectural view by selecting the framing icon. I'll select the exterior wall panel along the kitchen. Right mouse click and select Edit Parts from the menu. A new window with only the selected wall panel opens. Rotate the wall panel to access the framing. You can edit profiles by selecting grip points and adjusting the profile. And the same editing tools we previously covered are available. In this example, I'll make a few copies of an existing stud. To close the window, select the red X in the upper right corner. After completing all the wall framing edits, the next step is to create the panel drawings. Create the panel drawings for individual walls or for all the walls in one step. It's important to note, if panel drawings already exist and you select Create Panel Drawings, a window prompting the user to either replace or update the existing panels will appear. Replacing the panel drawings will delete the existing panel drawings and prompt the user to select a new wall panel template. Updating the panel drawing will keep the existing drawings, but update the material schedules and the existing drawing and elevations on the panel drawing. Let's create a panel drawing for an individual wall. Select the wall panel label, right mouse click, and select Create Panel Drawing. Next, select a wall panel template from the panel drawing libraries. I'll select the wall panel A 11x17 template from the wall library. Select OK to create the drawing. Vertex builds the wall panel drawing. It adds the elevations and cross sections, and adds any material schedules that are part of the panel template. The wall panel elevation shows the sheathing outline and sheet label. It also shows the label for each individual framing member. Wall dimensions and a cross-section view are also shown on the drawing. The material list, found in the lower left corner of the panel drawing, includes the labels for each of the framing member, the quantity, material, description of the piece, and the length of the piece is also included in the piece list. The sheet schedule is found in the lower right corner of the panel drawing. The sheet label, quantity, material, and a description which shows the dimension of the sheet is included in the sheet schedule. To close the panel drawing, select the X in the upper right corner of the window. Another way to create panel drawings is to go to the Output tab and select Panel Drawings. An Element Drawings panel will open on the left side of the UI. The panel lists all the floor and wall panels in the project. The panel label, drawing status, floor level, and type of numbering is displayed. The panel drawing will display OK if the panel is up to date, or it may display out of date if the panel is not in sync with the model. To create multiple wall panel drawings from the Elements Drawing panel, select a panel, keep your finger on the Shift key, and select another panel in the group. Right mouse click and select Create. Next, select a panel template from the Panel Drawing Wall library. Vertex then creates the wall panel drawings for each of the selected wall panels. The drawing status for each of the wall panels changes to OK, indicating the wall panels have been created and they are up to date with the project. You can open a panel drawing from the Elements Drawings panel. Select a panel, right mouse click and select Open. You must select Exit in the Elements Drawing panel before you can access the panel drawing. You can also open a single panel drawing by selecting the panel drawing label, right mouse click and select Open Panel Drawing. We completed panelizing all our first level walls. Now if you recall, in our project parameter settings, our first level walls were set to frame full length. Next, we'll panelize the walls for the second floor level. Under project parameters, for the second level walls, we set our preferred lengths to 16 feet, 12 feet, 8 feet, and 4 feet. Those will be our typical wall panel lengths for our upper level walls. Let's switch to the second level wall layout. Go to the Drawing Model Pairs icon and select Second Level Wall Layout. Since we have already set the preferred wall panel lengths in the project parameters, manually adding panel breaks is not necessary. Panel breaks will occur automatically using our preferred lengths. Let's generate the wall panels. Under the Modeling tab, select Wall, and Generate Panels in the menu. Under the Wall Panelizing Settings window, we will leave all the settings as is. Select OK. Next, let's select all the walls to panelize. Click on the upper right corner, and keep your finger on the left mouse button, and drag a selection window down to the lower left corner. Ensure that all of the walls are inside the selection window. Now right mouse click and select OK, or press the V key to confirm the selection. We now have all the wall panels for the second level walls. The next step is to generate the parts for the wall panels. Go up to the Modeling tab, select Wall, and Generate Parts from the menu. Again, we will drag a selection window around all the wall panels. Right mouse click and select OK, or press the V key to confirm the selection. Vertex then goes through the process of generating the wall framing for all the wall panels. To view all the wall panels, go to the Output tab and select Panel Drawings. You'll find all the second floor level wall panels have been added to the Elements Drawings panel. Let's create the drawings for only the second level walls. Select the column header titled Floor to organize the list by floor level. It makes it easier to select only the second level walls. Select the second level wall on the top of the list. Next, press the Shift key and select the last second level wall in the list to group select all the second level walls. Now right mouse click and select Create. Select the wall panel A 11 by 17 wall panel template drawing under the Walls library. Vertex then generates all the wall panel drawings. Select Exit to close the Elements Drawings panel. To open a panel drawing, select the wall panel label, right mouse click and select Open Panel Drawing. I selected the wall panel from a 30-foot long wall. As you can see, this wall panel was set to our maximum wall panel length of 16 feet. Select the X in the upper right corner to close the panel drawing. Let's view the wall framing in 3D. Select the F2 key to switch to the 3D view. And switch from the architectural model to the framing model by clicking on the house icon. Rotate the model to see all of the framing components. To rotate in 3D, press down on the middle mouse button and move the mouse while the button is pressed. Use the mouse wheel to zoom in and out. Let's hide the wall sheathing, so we only view the wall framing members. Select the sheathing panel, and then press the Control key and the A key to filter select all the panels, and select the H key to hide the sheathing panels. Rotate to view the model from different angles. Let's hide the first level wall framing. Confirm the Model tab is active. Go to the lower left corner and select the Model tab. To close all the branches, select the Collapse All tool, which is the black triangle. Now expand the first floor branch. Next, expand the Panels branch. Select and right mouse click on the Wall Panel branch. In the menu, select Hide to hide the first floor wall panels. Now let's hide the first level floor framing. Under the first floor branch, find the Plane Structures branch, select and right mouse click to bring up the menu. Now select Hide. Only the second level walls are visible. To unhide the objects, right mouse click on the background and select Restore Hidden. Select the F2 key to go back to the 2D view, and switch back to the architectural model by clicking on the house icon. Now that we have the wall panels for the first and second level walls, let's switch back to the first level wall layout and export to a PDF booklet. After all the panel drawings have been created, you can export them to a PDF set. Go to the File tab, select Export, and select Print PDF Sets. In the Select Set and PDF Type window, scroll down and select Panelized Wall Set. Select OK. Enter a file name or select OK to accept the default name. Vertex finds all the panel drawings in the project and adds each drawing to the PDF set. Once it's done, your default PDF viewer opens the PDF set for viewing. Vertex compiles all the wall panel drawings in the project into a single PDF. This concludes the wall framing tutorial for the steel version of Vertex BD.